In organic chemistry, one of the important named reaction is aldol condensation. Most of the students facing the problem. Today I'm just going to explain an easy method. Just follow me step by step. I'll start from zero and I'll take to you advanced level. Okay, let's get started. Aldol condensation. So before going to this aldol condensation, first we need to know some fundamentals. So first we'll learn the fundamentals, and then afterwards the total aldol condensation is very easy. Okay, so first so before aldehydes and ketones we know, right? Aldehydes and ketones, one common thing, this is C double bond O group, right? So the C double bond O group, oxygen is more electronegative, right? Partial negative charge, here is partial positive charge. Partial negative, partial positive. Aldehydes, ketones undergoes which type of reactions? Which type of reactions? Nucleophilic addition reactions. Nucleophilic addition reactions. This is the first important thing which we need to know. Whenever the aldehydes and ketones, they are undergoing which nucleophilic addition reactions. What is nucleophile? Nucleophilic addition reactions. Nucleophile means, right, negative charge species. Generally, negative charge species, electron excess species or electron donating species. Nucleophiles are two things or two types, charged particles and neutral. So negative charge, for example, Cl minus, Br minus, I minus, OH minus, Tn minus, like that. Nucleophile. Addition means simply we are adding nana. We are adding the nucleophilic addition reactions, adding. So for example, try to understand, C double bond O is there, one nucleophile. Addition means just simply adding, nothing is there. So because carbon is partial positive charge, positive because of the electronegativity difference. It's coming and attacking over here. So C double bond O will get O minus, nucleophile is here, this. So first try to understand nucleophilic addition reaction. Nucleophile, just we are adding to the aldehydes and ketones. Aldehydes and ketones undergoes nucleophilic addition reactions. First point which we need to know. Then second case. So second point which I am going to tell you, second point. So before 1 second I'll just discuss about this RC double bond OH. For example, try to understand aldehyde. When nucleophile coming and attacking over here. So R, P, O minus, then H nucleophile. Nucleophilic addition reaction. For example, R, C double bond O, H, HCl. So what we will get? R, P, O, H, H, Cl. What exactly happened? HCl undergoes H plus plus, Cn minus. H plus is nothing but electrophile, Cn minus is nucleophile. Right? First nucleophile is coming and attacking. RC double bond O, H plus Cn minus. Cn minus is what? No. Nucleophile. So which reaction we are doing? Nucleophilic addition reaction. Always carbon is having the 4 bonds, right? So if the nucleophile is coming in and attacking over here, so carbon will get the 5 bonds. That's the reason one bond is breaking, it's going to the oxygen. So R, P, O minus, H, right, Cn. Then afterwards the H plus coming and attacking over here. This is R, OH, H, N. So first thing, whenever we are just learning the aldehydes and ketones, first we need to understand what is nucleophilic addition reaction. This is the foundation for aldol condensation, nucleophilic addition reactions. So I'll give you a couple of examples. Either aldehyde or ketone, whatever it may be, HCN. What exactly we will get? OH, it is Cn, hydrogen. Even you can take the hydrogen. If you take ketone, same, nucleophilic addition reaction. What exactly happens? Cn minus is coming and attacking over here. So here also Cn minus is coming and attacking over here. This is a nucleophilic addition reaction. First, we need to understand this. Second point. So in aldol condensation, aldehydes and ketones. Aldehydes and ketones. The adjacent carbon for the C double bond O. This we could say alpha carbon. Alpha carbon. This alpha carbon is having how many alpha hydrogens? 3 alpha hydrogens. 3 alpha hydrogens. Alpha. For example, this with respect to C double bond O, we need to see alpha, alpha. For example, try to understand CH3, CH2, C double bond O, H. So what is alpha? This is alpha, this is beta, gamma, delta, epsilon, like that, right? Alpha, at least first what we need to, second point, we need to identify the alpha hydrogen. What is alpha hydrogen? So alpha carbon is having the alpha hydrogen. So second point, first point I told you, nucleophilic addition reaction, nucleophilic addition reaction, nucleophilic addition reaction. First point, nucleophilic addition reaction. Second point, what? Carbonyl compounds. At least it should have one alpha hydrogen. One alpha hydrogen. Carbonyl compounds are either aldehydes or ketones should have at least one alpha hydrogen will participate in the aldol condensation. If there is no alpha hydrogen, so there is no aldol condensation. Okay, for example, try to understand HC double bond OH. This is a formaldehyde, right? It doesn't have any alpha carbon, so no reaction. Benzaldehyde. Benzaldehyde. So alpha carbon is there, but no alpha hydrogen. Okay, so this type of compounds won't participate in the aldol condensation. So the two important things which I told you right now. And third pointer, so which reagents we are using? Dilute bases, KOH or NaOH, K2CO3, Na2CO3, barium hydroxide or calcium hydroxide. Just note these reagents. Sometimes, so generally we'll use KOH or NaOH. Sometimes they are giving the K2CO3, Na2CO3 or barium hydroxide, calcium hydroxide, right? So first I'll explain mechanism and I'll explain the shortcut tricks how to solve this question. First I'm writing aldehyde, CH3, C double bond OH, aldehyde. Presence of base, any base we can take, dilute base. Generally we should take 2 moles. Sometimes they didn't give the 2 moles, but we have to take 2 moles. So first I'll write the product, then we'll see the mechanism. Chalo. So first we'll get the compound is like this, CH3, COH, H, CH2, C double bond O, H now. Here is the product is, this is alpha, right? Alpha, beta. Beta hydroxy carbonyl compound or beta hydroxy aldehyde also we can say. Beta hydroxy, simply we can say carbonyl compound. Carbonyl compound means what? Aldehydes, ketones combinedly were called as carbonyl compounds. So then afterwards, if you are heating this compound now, water is going out, we will get CH3, CH double bond CH, C double bond OH. So this we could say alpha beta unsaturated. Saturated, unsaturated, right? A double bond and triple bond were called as unsaturation. Alpha beta unsaturated carbonyl compound. Alpha beta unsaturated. So actually this is the first equation. This is the reactant. Reagents we can use any of this, means bases, and product. Products are 2 types. So after removing the water, we will get this final product. So now I'll explain the mechanism. In the mechanism, Nana, very easy. First I'll give the total reaction, CH3, C double bond O, H, phase, 2 moles. I'm just speaking keep on alpha hydrogen, right? When we are using the base, Nana, this base, it obstructs this H plus. OH minus and H plus. Water is going out. What we will get? CH2, negative charge, E double bond O. This negative charge, carbene ion is forming. So it is resonance with the carbonyl compound. That's why this is stable. And one more important thing, it acts as a nucleophile. I told you, aldehydes and ketones undergo which type of reactions? First, nucleophilic addition reactions, right? So we took 2 moles. First, I took the only 1 mole, and second mole I am just taking here. This is a first reaction. Second, very simple. So here is, this is nothing but acid-base reaction. Now this is acid-base reaction. Now here is CH3 C double bond OH. The product which I am taking here. I told you aldehydes and ketones undergo which type of reactions? Nucleophilic addition reactions, right? Now the OH minus is attacking over here, no? Simply I told you nucleophilic addition reaction. Nothing is there. Acid base nucleophilic addition reaction. Simply club the 2 products. CH3 CO minus. H I am writing like this, CH2, C double bond O. So this is particular one, no? This particular one came from over here. Simple. Third step, nothing is there. Simply add the H plus from water, O minus H, CH2, C double bond O, H. It's taking the, because already water is there, so it donates the proton. Add H plus simply, CH3, OH, H, CH2, C double bond O. Already we got the product, beta hydroxy, simple. And fourth step, CH3, C double bond, COH, CH2, C double bond OH. In the basic medium we are doing this, right? So this is undergoes E1CB mechanism, no? E1CB mechanism. So here from OH and here from first the base is taking the, here is the hydrogen. First the base takes the proton H plus. So here is negative charge is forming. So the OH is going out like this. I'll explain this clearly. We'll get CH3, CH double bond CH, C double bond O. So E1CB. So we had E1, E2, E1CB, no? So I'll explain in a shortcut method what exactly E1, E2 and E1CB. Directly I'm explaining the E1CB. So for example, here is the hydrogen, here is the living group. I'm using the base. The first base obstruct this proton, right? So then C negative charge, H, C like this, L. Then in the next step, what exactly happens? The negative charge coming here, living group is goes, right? So we'll get C double bond like this. So here in the mechanism, the total mechanism, this is first acid base reaction, and second step, this is RDS, rate determining step. Rate determining step. The third step, just we are adding the H plus. In the fourth step, E1CB mechanism is taking place. So a lot of people are confusing here, so I'll rush once again. I'll write this E1CB in clear mode. So CH3, COH, right? CH. I'm writing the H here above. Right now. So first the base, what I told, this base obstruct this proton. So then what exactly happens? We'll get the negative charge. Then the negative charge coming over here, right? So the OH is going out. Simply this reaction takes place. This reaction takes place. These are the 4 steps. First, alpha hydrogen. Just remove the alpha hydrogen. Simple. I told you the first thing, aldehydes and ketones undergoes nucleophilic addition reaction, right? First, whatever the aldehyde is, 2 aldehydes, 2 moles we took, right? So the one is acts as a nucleophile, nucleophilic addition reaction, add H plus, remove the water. These 4 steps. Okay? Nothing is there. So first what we need to cross check, whether the aldehyde or ketone is having the alpha hydrogen or not. We'll see some more examples. CH3, T double bond O, TH, OH minus. Right now, 2 moles I'm just taking. 2 moles. Directly I'm writing the product CH3, COH, CH3, CH2, C double bond O. The mechanism is same. The first step what we need to do? First step, after removing the water molecule, heating, water molecule is going out. CH3, CCH3, double bond H, C double bond O, CH. So I'll explain once again in a different shortcut method. The same reaction. So first step, take the alpha hydrogen. More important, both are having the alpha. No issues, you can take anything. OH minus, directly I am writing CH2 negative charge, C double bond O, CH3. Now I am just taking the second molecule like this, CH3. I am just changing the color to avoid the confusion. Now what exactly happens is RDS, nucleophilic addition reaction takes place simply. How we will get the product? CH3, CO minus, I am just writing like this, CH3. So here onwards I am writing the color. CH2, C double bond O, CH3. I am adding the H plus here itself and remove the water directly. CH3, CH3, double bond CH, C double bond O, C. That's it. Nothing is there. First remove the alpha hydrogen, nucleophilic addition, add H plus and remove the E1CP mechanism. Simple. Got it? But 90% of students, they are doing the mistake in this question. CH3, CH2, C double bond OH. I am giving like this. They'll write the mechanism is, they'll write the product is like this. CH3, CH2, COH, H, CH2, CH2, C double bond O. So 90% of students, they'll write this one. So I'm just writing this. Okay. Because they removed the beta hydrogen. What we need to do? Simple. In the first step, CH3, CH, H, C double bond OH. Simply alpha hydrogen we need to remove. Alpha. Then CH3, CH, negative charge, C double bond O. The first step. The second step, same nucleophilic, because we are taking the same type of aldehydes, right? Aldehydes are ketones. Here is CH3, CH2, C double bond OH. Now the CH negative charge, I am writing the CH3 up. C double bond OH. So 90% of students here, they will do the mistake. Right? Nucleophilic addition reaction. Then get this product. CH3, CH2, OH, I am directly writing the OH, EH. You can write CH3 up and down, doesn't matter. And remove the water. CH3, CH2, EH, double bond C, CH3, C double bond O. That's it. This is the way which we need to. Now in these 3 cases, if they are asking the final product, I'll tell you one simple logic. I'll tell you one simple shortcut trick here. If you know the mechanism, that would be far better. No sir, I'm not having that much of patience. So you can follow this method. For the lazy people, I'm just telling this. CH3, T double bond O, H. Can we write like this? Second molecule, alpha hydrogen, H2, TH, T double bond O, H, 2 moles. Simply, what you need to do? Remove the water molecule. Get this. That's it. Be careful. We need to remove the hydrogens from alpha carbon. Alpha carbon. Where we are removing the alpha hydrogen directly. So in this case also we can do. So this is a mechanism, of course. Here also same thing which we can do. How can we do? CH3, T double bond O, CH3 and H2, TH, T double bond O, 3. Write like this, remove the water molecule. Right, if you remove the water molecule, directly you will get the final product. Like this. This is normal Aldol condensation. Right? Here also we can do. How can we do? CH3, CH2, T double bond OH and H2, T, CH3, T double bond O. Move this water. Okay. But knowing the mechanism would be better. Nothing is there. Remove the alpha hydrogen, nucleophilic addition reaction, add H plus, remove 1. Simple. Anything would be fine. Next, crossed aldol. For example, same mechanisms, but just try to understand the process. CH3, T double bond O, H, CH3, double bond O. So earlier one molecule we took 2 moles, but here is 2 different. Simply try to understand. This is A and this is B. We are just taking 1 mole. 1 mole means 6.023 into 10 to the power of 23 molecules are there. Right? Simply earlier case, take one box. I'm just taking only one type of A's, Nana. So what type of product we got? AA type, simply. Now what I'm doing? AA along with, we are adding BB also. How many combinations will you get? Let me know. How many combinations? You can get AA, right? BB, AB, PA. You get 4 products now. 4 products. Means take this is 2 moles like this, 2 moles like this. First AA, nothing but I am writing the 4. First reaction which we did, right? This is one type of reaction is takes place. Second type of reaction is like this, CH3C double bond O, CH3. Third one the CH3, T double bond OH, CH3, T double bond O, CH3. One more time, and you can exchange like this. 1, 2, this is 3, and 4th one is reverse it. So imagine you are removing the alpha hydrogen, you are attacking over here. Here also remove the alpha hydrogen, attacking over here. The 2 molecules already we did. This is a crossed one. And sometimes they are giving the ring type of compounds. In NEET and JEE Mains, they are asking this type of questions very frequently. Simply, what we need to do, if you know the mechanism, it is very easy. How? This is alpha, right? So any alpha hydrogen, just remove it and simply nucleophilic addition reaction. Nucleophilic addition reaction. That's enough. Then add H plus, remove. So simply how we will get? Directly writing the product. So like this we will. Okay. Next, intra-aldol condensation. within the molecule. For example, CH3 C double bond O H2 CH C double bond O. You know the mechanism, that's the reason I told you the mechanism. So first what we need to do in the mechanism, we need to remove the alpha hydrogen. First identify the alpha. This is alpha, 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 alpha. With respect to this one, both are alpha, alpha. With respect to C double bond O group, both are alpha, alpha. Now try to understand, it is a symmetrical molecule, no issues. We can take this alpha hydrogen and this. For example, if it is adding to over here, 1, 2, 3, 4, 4-membered ring we will get now. If you are removing the alpha hydrogen from first case and if you are adding over here, we will get 6-membered ring. We know 4-membered ring, 5-membered ring and 6-membered ring. 6-membered ring is more stable. So that's the reason what we need to, this one, just don't take, right? Just take this one. Just take this one. Alpha carbons. Now remove the alpha hydrogen over here, just simply add the nucleophilic addition reaction and it's a number game. Simply I'll tell you. So I'm just removing this. I think you got this one, right? 1, 2, 4, 5. Just give the numbering like this. Lot of students are facing the problem from this compound to ring cases. Blindly just write the 6-membered ring. Blindly write the 6-membered ring. Simple. So how many member ring we are getting? 6-membered. Blindly write the 6-membered ring. And give the numbering as your wish. I'm just giving 1, 2. If you want to write like year or year, doesn't matter. 1, 2, 3, 4, 5, 6. See, Nana, at second position, what is there? C double bond O. Just write the C double bond O. And the new bond which is formed between 1 and 6. This is, I'm just showing with this is one new bond. At first position, at 6th position, what is there? O minus and CH3. So I didn't do anything. Simply we just copied from over here. So then add H plus, and remove the water molecule. So directly we will get the compound is like here from the hydrogen. If you are removing C double bond O, the compound. So don't confuse, nothing. So just follow the fundamental principles. First, aldehydes and ketones undergoes nucleophilic addition reaction. Remove the alpha hydrogen. Everything is same. Then nucleophilic addition, add H plus and remove the water molecule. Simple. This is intro. And more important thing, here is somewhat advanced questions they'll ask. In nucleophilic addition reaction, aldehydes are there, ketones are there, right? In inductive effect, which I explained, which is more reactive, right? Obviously, it is 2 hydrogens are there. They won't donate any electrons. There is more positive charge. This R group is donating the electrons. Positive charge is somewhat decreased. These 2 are donating. Positive charge is further decreased. Positive charge is further decreased. Okay. So now formaldehyde. This formaldehyde is more reactive in aldehydes. Aldehydes are more reactive than ketones. So generally formaldehyde is, we could say, superaldehyde, of course, but this is not participating in the aldol condensation. Leave it. It's undergoing Cannizzaro reaction. I'll explain the next example. Aldehydes and ketones both are there. So aldehydes are more reactive because carbon is having the more positive charge. In case of ketones, 2 reasons. Reason number 1 is inductive effect because both are donating, and reason number 2 because of steric hindrance, bulky groups. Steric hindrance is there. So because of that, right? So these things, this is the level 1 which we need to understand in the aldol condensation. The level 2 advanced level, we'll do some more questions. This is the first part 1. For advanced, I'll do some more. So once again, I'm just keep on revising the everything which I did from the starting. Right now. The first thing which I told you, first aldehydes ketones undergoes nucleophilic addition reaction. First point which we need to know, right? And second, nucleophilic addition reaction which I explained, how the nucleophilic addition reactions takes place. And condition number 1, the first nucleophilic addition, second we need to identify the alpha hydrogen. The C double bond O adjacent carbon were called as alpha. At least we need to have one alpha hydrogen. The condition number 2. And so we need to use these bases, dilute bases KOH, NaOH, K2CO3, Na2CO3, so barium hydroxide and calcium hydroxide. And this is the first basic mechanism reaction I gave you. So this first, we need to remove the alpha hydrogen and it acts as a nucleophile. Nucleophilic addition reaction, this is RDS. Then add the H plus and remove the OH. So like E1CB mechanism in basic medium. This is one more example, same, I gave you the shortcut even. And this is the most important thing, 90% of students are doing the mistake over here. And this is a cross, this is intra, and some more also is there. So I'll give you some questions, just practice. So from this, already I gave you. So once again, I'm giving you. So question number 1, CH3, C double bond O, H, OH minus, CH3, CH2, C double bond OH. The bases I told you, you can take, I gave the list, right? Practice by your own. Take 2 moles wherever it required. This is level 1 only, I am telling you. Level 1 only. Take 2 moles wherever it required. 2 moles here. Here also you can take 2. So I can give you more examples, but these are enough. First practice it. So if you didn't get anything, so just comment below in the video. So I'll do one more video, right? Thank you guys.